In the last video, we were talking about the classification of electrons. And so here's the details about that. We're either going to call electrons valence electrons, or if they're not valence, they are called core electrons. The core electrons are closer to the nucleus. The valence electrons are closer to the outside, and the valence electrons are the ones that are most important. We're going to do a lot in the next chapter with valence electrons. But again, nice thing, the valence electrons are given to you right on the periodic table. And we're only going to look at S block elements and P block elements for valence electrons. So S, if you're in a S block, the number of valence electrons is simply the last digit of the group number. So that means in the S block, we're talking about the outermost S electrons only. So for example, the element barium, number 56. That's an S block element, and it's found in group number 2. So barium has 2 valence electrons. Notice there, the 1s is full, 2s is full, 3s is full, and so on. So we're only talking about the outermost, which would be the 6s, the 2 electrons found in that 6s. If you're in the P block, the number of valence electrons is still equal to the last digit of the group number. The only difference is now we're talking about the outermost S's and the outermost P electrons. So we were talking previously about germanium, number 32. Germanium is found in group 14, and the last digit of 14 is 4, so an atom of germanium has 4 valence electrons. And those 4 valence electrons are the outermost S's, the 4s, and the outermost P, the 4p. Now that should remind you of what we did much earlier this semester when we were talking about ions. We used the periodic table and we used the last digit of the group number to help us figure out the charge of ions. And this is where those rules come from. Now that you know about quantum numbers, now that you know about orbital diagrams, now we can understand why calcium makes a positive 2 ion and oxygen makes a negative 2 ion. Remember that metals are going to lose electrons, and so they form cations. And nonmetals, instead of losing electrons, will gain electrons, and they'll form anions. So why is that? Why is the difference between metals and nonmetals? If we had a metal such as sodium, and we draw out the orbital diagram, we'll find it has a neon core and 1 electron in the 3s subshell. We know from previously this semester that sodium loses 1 electron to form the sodium cation, and that electron that gets lost is the valence electron. So if sodium lost that 1 electron in the 3s, all we would have left is the neon core. And neon core is stable because that matches the stable configuration of noble gases. If we're talking about a nonmetal like fluorine, fluorine would have a helium core, 2 electrons filling up the 2s, and then the 2p is almost full. It has 5 electrons in that 2p, and fluorine turns into fluoride by gaining 1 electron to form a -1 ion because it has space in that 2p for 1 additional electron. So if a fluorine atom came in contact with a sodium atom, this electron would end up being stolen by the fluorine, and by doing that, the sodium reaches noble gas stability, and so does the fluorine, because having 2 electrons in the 2s and the 2p full with 6, this is the same as neon. So again, we're reaching that noble gas stability. Metals do that by losing electrons. Nonmetals do that by gaining electrons.